Good afternoon. I welcome you all to this refresher course organized by Ocean Engineering Department of IIT Madras. Myself, Sudipto Chakraborty. I had the opportunity to be associated with the largest dredging project ever done in our country. That is JNPT's channel. 33.54 kilometer long channel was dredged at a time. It was the combined channel for Mumbai Harbour and Jawaharlal Nehru Port Trust. And later I was associated with development of the 4th container terminal for Jawaharlal Nehru Port Trust. Good afternoon, everybody, and namaskar. Myself, Sudipto Chakraborty. I will be presenting a case on stability of slopes at the interface of reclamation and dredging. I will start sharing the screen such that I can directly go to the presentation, whatever I have prepared for presenting before you. In the 4th container terminal, actually, the container terminal was to be placed on a reclaimed ground of a large area. 90.46 hectare of land was reclaimed from the Arabian Sea, on which the load of the container terminal was supposed to be placed. Now, in this way, it's similar to Maasvlakte in Rotterdam, where they have eaten away the sea for 5 kilometers. Here also, the reclamation was to be done for a few kilometers from the shore, but at the end, a facility for berthing of vessels was to be created. That is, one jetty was constructed at that particular place where the design vessel size of 18,000 TEU vessels were supposed to be berthed. Now the issue developed that when the vessels will come, due to the hydrodynamic turbulence during ship's berthing, because of the movement of the propellers and the bow thrusters, while the vessels will be coming for berthing, there will be a particular critical velocity. Then due to the turbulence, the soil available over there at the seabed is definitely going to be scoured. Now the issue was that how to stabilize the slope at the juncture of the interface of the dredging and reclamation. This is one unique experience. Here there are a lot of technical intricacies about the design of that slope, which I will come to you through my slides. As you all know, the location of Jawaharlal Nehru Port Trust is here being shown, and these are the 3 terminals. And this particular picture, what is shown from Google image, actually this is the 4th container terminal, where the total area to be reclaimed was, as I said, 90.48 hectares. Here I am showing the image of Jawaharlal Nehru Port from the seaside. This particular 4th container terminal of Jawaharlal Nehru Port Trust had different components in that project. This was designed with a capacity of handling 4 million TEUs per annum. The project had components like one wharf, 1,000 meter, 1 kilometer wharf at the first phase with some approach bridges. Then near the jetty in the maneuvering area, dredging was required to be done up to minus 13.1 meter, and particularly at the berth pocket to accommodate laden 18,000 TEU container vessels. That is, when the ship will be squatting, their additional dredging up to minus 16.5 meter was the requirement. This shows the existing channel of the Jawaharlal Nehru Port Trust. This is basically from British Admiralty chart, which this particular channel was required to be dredged. As you know, India's largest container port is Jawaharlal Nehru Port Trust. This is the government-owned port, and it handles about 60% of the total containers handled by India. I'm showing you a layout picture, which was basically a satellite picture. It's obtained from Google, and then the configuration of the area to be reclaimed and traced has been highlighted here by red color. Here the jetty will come. This is the backup area of the container terminal. This is the area which has been reclaimed for the roads and railway access, etc. The terminal was designed for a design vessel of 18,000 TEUs, and the largest vessel of obtained from Marx. I'm showing here to show you the magnanimity, that the huge capacity of the vessel which the port could handle. That is the objective. I'm going back to my last previous slide, where I'm showing this particular triangular area, where the area is required to be dredged up to minus 13.5 millimeters chart datum. In the first phase of the dredging, actually several very high capacity of hoppers, of drilling suction hopper dredgers were brought from Holland by the contractor Boskalis. Boskalis is the largest dredging contractor in the world as per their association with IADC, International Association of Dredging Companies. They even brought very large capacity TSHDs named as Queen of Netherlands, then HAM 318, which had the capacity of 35,500 meter cube. In this particular first phase of dredging, what happened, gentlemen, in this western part of our country, the Mumbai port and Jawaharlal Nehru port originally had a draft of 10 meter. It was never dredged before. Now, when in 2012, the dredging contractor came for dredging, they faced some challenges, and the management of the project also was a bit difficult from contractual point of view, and how to solve the issues, etc. Unfortunately, some bombs also were found below the bed level of the sea, and here in this slide I am showing you the picture of a bomb cell at the drag head of the TSHD. People are doubtful whether the bombs can explode, so Indian Navy was called for to examine the things, and while finding out the reason for finding bomb cells inside the sea, which is very unique, and never in any dredging project nobody has encountered such thing. The issue was examined historically, and if you go back to Google, you can find out in Wikipedia there is a story about one ship wreckage. In 1944, the British government was taking away some gold bars and arms and ammunition from India during that post-World War period. And actually, unfortunately, about 40 kilometers away from the shore of Mumbai port, that vessel exploded. So that is supposed to be one of the causes for having these underwater obstructions, which included bombs also. The underwater obstructions also included left out containers, hatch covers, and even tractor trailers and huge items. Now the question is, in a capital dredging project, when the contractor is supposed to dredge soil or rock, whatever is available, whether taking out the underwater obstructions will be a duty of the contractor, whether the charges, the efforts taken by the contractor for taking out these underwater obstructions will be payable or not. So these are the contractual issues, and actually that created what I call as the challenges encountered in the dredging project. Some of the pictures are showing what are the kind of objects we have faced, including the dredging contractor has even encountered with sulfuric acid barrels and which one came into contact with the air. Some fire was found on the vessel, so they had to take a lot of precautions. They brought some bomb expert and explosion experts from Belgium, and that was a huge kind of hue and cry everywhere. But finally, the project was closed. Now, if I talk about the berth pocket area of the fourth container terminal, the layout of which I have already shown to you, here in this triangular portion with different colors, we're showing the area marked as D1, D2, D3, D4, etc. as the area to be berth, before berth, to be dredged for up to minus 13.1 meter, and this area marked as W1, W2, that is in front of the berth, we call it the berth pocket, is the place where the dredging was required to be done up to minus 16.5 meter of chart data. The entire container terminal was built by reclamation of soil inside the sea. The soil was collected from nearby places, nearby small hillocks around the villages around JNPT area, Udan area, up to Palasfata, near to Belapur, wherever something was available, like granular materials were required to be used for consolidation, for getting the land reclaimed, because the marine clay which was available in the sea was not suitable for the purpose of reclamation, because that had very high liquid limit and it was not supposed to carry the load from the container terminal. The container terminal, as you can expect, is supposed to have a very highly thick band of concrete pavement, heavy duty pavement, on which the rails will move, the tracks will be laid, and the RTGCs, rubber tire gantry cranes, the RMQCs, etc. will move. So it always encounters a huge load, and maybe sometimes we can bring some recent, even better machines like straddle carrier or whatever, and because the vessel sizes are going to increase every day. So in this case, whenever the up to minus 16.5 berthing is possible, so we had to design this particular pavement of the container terminal, considering all the possible loads over there. This is a chart which shows that in the maneuvering area of the vessels, where actually in this case of open sea, a turning circle is not required. Here we call it only maneuvering area, where the vessel is being turned and such that the starboard side and port side marine activities can be managed. Here we talk about the depth of the dredge level up to minus 13.1 and minus 16.5 at the berth pocket. This slide shows about the soil parameters. Initially at the top level up to 20 meter thickness, a soft layer of soft clay was obtained where the liquid limit was 93 and the plastic limit was 57. N value you can see is very poor here. It could vary from 0.88 to 4 only. Now in the next layer, there have been some firm to stiff clay, and these are the things which had to be dredged. And dredging of something like toothpaste, something like curd, is very difficult, So the dredging companies had to decide for a special type of dredging equipment. In this particular project, plow dredger was used for dredging, along with grab dredger and trailing suction hopper dredgers and cutter suction dredgers. Trailing suction hopper dredgers and cutter suction dredgers are always very common in all projects. Grab dredgers are also to some extent common, but plow dredger is not very common. The plow dredger is actually using some metal plate which behaves like a plow. Plowing we do in the agricultural field. Our Indian peasants are very much familiar with the cows and the plowing. So that kind of some movement of clay, marine clay, by plowing was done for this particular depth of the soil, because from -4 of chart datum to -6 of chart datum, TSSD could move because TSSD had a particular draft. Unless the soft soil was removed by the plow dredger, this is a special efficiency of the Dutch and the Belgium based dredging contractors who have thought for it that it will be easy for taking out the mud. This is regarding the plow dredger, as I was talking, they actually use a kind of metal plate which actually removes the clay just by sliding, as if just by taking you're taking a using a spoon or a knife in the batter. That kind of thing happened, and that they basically manage by with the help of one A-frame which is attached with a hanging plowing plate. In this particular project of fourth container terminal, they used this trailing suction hopper dredger named as Brebo. The technical details are here shown. They also used another dredger, trailing suction hopper dredger TSSD Antigone. In this slide, the technical details of that particular dredger is being shown. And after dredging, as per studies done by CWPRS, Central Water Power Research Station, Pune, the dredge spoils were advised to be dropped at a particular place which is about 35 kilometers from the work site, because after dredging, where do you dispose the dredge spoil? So there is a particular place named as for dredging disposal site. They don't call it DS3. DS means dredge spoil. So the particular coordinate of that particular place is shown here, where the vessels, I mean the TSHDs, used to go and disperse the dredge spoil. The idea was that we should not disperse in a place where the sediments will come back into the channel. You can see this is a very mega project, very large project. 90 hectares of land was reclaimed for the purpose of, and we are showing some gantries, etc. A lot of activities are going on. This is a picture showing the hugeness, the very big size project. Fourth container terminal is basically a pride of India, as I was talking at the beginning, that it resembles something like Maasvlakte in Rotterdam. Now, how to do the reclamation? If we talk about the basics of reclamation, reclamation can be done by drained method or by dredged method. In the drained method, the soft marine clay lives in place and consolidate the clay with the help of the vertical drains or with or without preload. But in our case, we did not go for consolidation of the marine clay, because here the marine clay's liquid limit was so high that draining out the water available there, the moisture content by PVDs was difficult. So in this case, we have used the dredged method, that the soft that means the soft marine clay has been dredged at first, then disposed in the DS3, and then backed by dredged depths by suitable incompression material, incompressible material such as sand. Here we could not get so many cubic meters of sand. Actually, 50 lakh cubic meter of soil was required. So we collected some muram from the local places. You can see the color of the soil is slightly towards red or yellow, which means that some kind of hematite content could also be there. Muram is a local term basically. Now, after driving the PVDs, the prefabricated vertical drains, when the capillary expulsion of water was obtained, then as per the codal provisions, a drainage layer was being developed over there for taking the coming out of the water from below. This is a process in the consolidation. And in this slide, we saw the huge activities in the project, because at least about 1,500 to 3,000 dumpers used to ply in the site every day. And for carrying the muram from the locally available hills, hillocks, we call this as land waste filling using soil. We're showing you some pictures of removal of the mud entrapped inside the sea. And actually, we have also faced mud waves, the huge pressure developed from the mud waves, which was a concern for all of us, because this mud wave had so much of pressure, so much of load it could give, that it could give some kind of failure to the existing structures if it was towards the sea, towards the port, and it has the capacity to move the huge mass of the reclaimed mass. And also, if any vessel is plying over there, the mud wave had that capacity to remove them. You can see in this particular picture, as I was talking, in a low tide condition, this is the mud, which actually was called as mud waves. Now, if we talk about the technicalities of the slope stability of the temporary and permanent edge, because once you reclaim something, reclaim an area, at the end of the reclaimed area, where it touches the water, there had to be some kind of a stable slope. There sometimes the slopes are riveted, and in the process, actually ground improvement, what we call as by driving prefabricated vertical drain, is the main thing. And for ground improvement, after driving PVDs, there was a surcharge height which varied from 3 to 5 meters as per the design load. It was designed by AECOM company, which is a very renowned company, having a lot of technical data analysis and computer programming, etc. They have come to a solution and they suggested, which was accepted by the client, that is Port of Singapore Authority. It was accepted by CGR, Cullen Government Row, the PMC contractor for them. And the process was followed by the companies who were involved in the construction, ITD cementation, and their subcontractors, dredging contractors, etc. The phenomenon in driving PVD, as you all know, that the water is being punched and is being coming out from the lower compressed soil, and through capillary action, this comes after the preload is put. And then for the purpose of horizontal drainage, one filter bed was also required to be placed over there with geometries and stone chips. If we describe the process of construction, what was adopted in the case of Jawaharlal Nehru Port's 4th container terminal, these are the steps. That is stage 1, filling up of the working platforming, which is above highest high tide level, that is 4.45 meters CD, plus 4.45 meters CD, chart datum. Then install the vertical drains, and also we require the field instruments to monitor the ground improvement. We had to wait for the intermediate pause period to improve the ground up to a certain degree and place surcharge up to the design level, then wait for final pause period and analyze field instrument data at regular interval. Remove the surcharge once the required degree of consolidation is achieved. Consolidation achievement was satisfied by tests conducted by geotechnical team. Then after the confirmatory soil investigation tests, the design assumptions were also validated, and then only the consolidation was considered to be satisfactory. The purpose of ground improvement, as we know, is to reduce the cost of post-construction settlement and increase the shear strength of clay and bearing capacity. The key factors are that we had to find out what should be the spacing for PVD. Here it was 1 meter to 1.5 meter, and field instrumentation used to be analyzed regularly by and increasing the we had to increase the preload to accelerate the consolidation. You can see how many large PVT driving machines were involved, and the mantles had to be driven, the PVTs had to be driven up to -16 or so. The weight was so bad, but this is a credit on the engineering efficiency of our people. I mean, our country's this kind of reclamation project, one of the highest volume reclamation project, on the largest area of reclamation, like Hong Kong airport was built on reclamation. Several such projects are there in different parts of the world, but in India, this was one of the highest and largest reclamation project. Now, when we come to the slope stability, the purpose is to avoid any kind of slip failure. Slip failures can be circular, slip failure may not be circular. It can depend on the shear stress of the particular soil. So this is the purpose of making the slope stable, just to define the issue. Now, the key factors which are important to be noted here are the stage construction, intermediate weighting, providing the gaining strength, then tensile geotextiles up to 1000 kilonewton per meter strength was used to enhance the factor of safety here within this filter bed, actually. Filtration, this horizontal filtration bed. Now, this is the kind of sectional elevation of the embankment after reclamation. So you see, this can be a failure plane from here. So depending on that, we have to make this particular slope as stable such that it doesn't fail. That is our objective. I'm showing you this as a part of the revetment where there was no interface of dredging and reclamation, but it was reclaimed, and the reclaimed end, the end of the reclaimed body was riveted like this. To talk about the field instrumentation and monitoring, piezometers were used to measure the pore water pressure. Settlement plates were installed, and magnetic extensometer was installed to measure the settlement, and we have used inclinometer to measure the lateral deformation also. These are some of the pictures taken during the progress of the project. Speaks about the filtration layer. Sometimes we have faced this kind of surface crack at the edge. Say at a distance of 10 meter to 15 meter from the end of the reclamation, we find this kind of a crack. So we had to repair this crack just by taking out the engineering measures. And why the crack have developed? The crack developed during low tide, because the water, when comes from the seaside, also gives a lateral pressure, which when the tide is low, the water is receded, then this kind of cracks happen. And there were issues of construction contractors, efficiency and insurance issues, etc., and lot of hue and cry, and finally again loading, again preloading, and again filtration, geometries, etc., were used to repair these kind of cracks. So these are the challenges I have been talking about. And another, as I said about mud wave earlier, these are some pictures we speak of the mud wave. I think this part we are looking at the elephant caves also, which is a little bit away from this particular area. It's not the elephant, it's the other side actually. Actually, the displacement of very soft mud caused by loading too quickly, because once you first place a mass of soil on the bed of the sea, what happens, that load replaces the mud, and the mud, due to its own property, moves around. It moves outside towards the sea. And the caution we had to take, that if there is any disturbed mud which is entrapped below the reclaimed soil, then it will definitely prolong the consolidation time because the water has to come out. And residual settlement also has an issue to do with the entrapment. So this was a challenge. This reclamation and consolidation, it itself is a challenge in the sea where mud is there. Now, what we've been talking about as the caption of this particular presentation, that slope stability at the interface of reclamation and dredging. Gentlemen, you see what is going to happen here. This is the reclaimed mass. This is the structure of the jetty. These are the piles. And this is the fendel line, that means the berthing line. So when the vessel comes, when the vessel comes here, it can squat in the berth pocket. So the berth pocket has been raised up to minus 16.5. Now the question is, this particular place, we are dredging. We are dredging here and we are reclaiming here. So this area I call as interface of dredging and reclamation. Now what is going to happen? When the vessels come, the vessels propellers are moving and the bow thrusters are moving. So these are creating some turbulence in the water. And that due to turbulence, actually, we all know that there is a critical velocity to pick up a particular size of a soil particle, which basically is the first phenomenon for scouring. Now, it had to be analyzed that what is the critical velocity, what is the particle size, and what can be the slope which will not deform even if when the ships are berthing. That is, during the hydraulic dynamic condition, dynamic hydraulic conditions during maneuvering of ships, the stability of the dredge slope at the end of the reclaimed mass here, the end of the reclaimed mass here becomes very critical, and it amounted to a kind of research. And at the end, I will refer some paper which was followed. That is Morgenstern and Price's paper on slice method of analysis, and they also used a particular computer program. When we talk about the critical phenomenon here, scour of dredge slope at the berth pocket and at the dredge slopes due to turbulence expected to be generated by lateral movement of bow thrusters and propellers during a berthing of the deep drafted 80,000 TEU capacity container ships under the action of waves, sea pores, currents for both short-term and long-term condition demanded analysis. Here I mentioned about the design vessel, what was considered. It was Mars Company's McKinsey vessel, McKinsey Moller. The location of the bow thruster was also important. In this particular vessel, the bow thruster is located at a distance of 12.5% of the width from the hull of this ship to the middle of the ship. So 12.5%. In generally, actually, what happens is usually for smaller size of vessels, the propellers are actually single propellers. But such kind of a bigger size of vessel, it so happened that there had been two propellers 24-meter apart. So you can imagine the turbulence is more. The distance between the tip of the propeller and the keel of the ship was 0.5 meter, corresponding to the diameter of the bow thruster. Because for 18,000 DWT ship, the bow thruster size is also not a small size, it was a huge size. And due to movement, while the pilots will berth the vessel, they develop a huge pressure, and which raises the water level. The displaced tonnage of water hits the place below the jetty, and it disturbs the slope. So that is the critical phenomena which is to be tackled. The criticality at the interface, if we list it out, as I already have pointed out, that potential scour can occur at the berth pocket and the dredge slips due to the hydraulic turbulence generated under the action of waves, sea pores, currents. Due to rotation of the propeller as well as lateral movement of bow thrusters during maneuvering of the design vessels. Now, what is the philosophy for design of the stability of the dredge slope? We have to see that the dredge slope does not fail. Here, Morgenstern and Price's theory of interslice force function from method of slices was considered, and slope W software was run to find out the slope. Within the framework of limit equilibrium methods of stability analysis, no restriction need to be placed at the outset upon the shape of the possible slip surface. This is the concept that the possible slip surface can be circular, can be parabolic, can be triangular, can be trapezoidal, or anything. It all depends on the phi value of the soil and the load which is disturbing the soil to fail. The critical surface may deviate significantly from a circle or a plane, and therefore a method that facilitates the analysis of surfaces of arbitrary shape is of interest. And that is why Morgenstern and Price's paper was given importance. This is the engineering criticality of this project, that at the interface of dredging and reclamation, the critical velocity of lifting the particle size of the soil available over there, and in fact that is also mud only. And the design philosophy itself includes that the solution of the governing equation ensures that all equilibrium boundary conditions are satisfied, because whatever slope we give, it has to be in equilibrium. We cannot allow the slope to go to other than equilibrium condition, such that if the slope fails, that means the jetty will have problem, the berthing will have problem, the reclaimed mass soil will be distorted, and lot of failure can happen. So this is the idea, and this is the design criticality of the subject of stability of the dredge slope. This method has been programmed for a digital computer, and some example of its application are given in that Morgenstern and Stein's paper. Comparisons are also made with other methods of analysis. Since the soil is cohesive in nature, the factor of safety has been calculated under seismic condition as per pseudostatic analysis, and the slope analysis has been performed in total stress method based on undrained shear strength for both temporary and permanent condition. On the other hand, the weak geotechnical parameter of the available soil was considered for slope stability analysis for eroded slope. The soft clay had an average cohesion of 9 kilopascal with a standard deviation of 6 kilopascal. So when assuming a diameter of 2 micron for the soil particles, the critical velocity was found to be within 0.7 to 1.5 meter per second. The effect of the scouring on the slope, it is considered that the toe of the slope after some time might recede, while the top of the slope will be affected. If the toe is affected, then the top will also be affected. So scouring has to be avoided. Now, after design, what was obtained, I'm coming there. Before that, I just read out the assumptions made in this analysis. That these are the assumptions that the lifespan of the port was 50 years. The new terminal of the port will approximately receive about 3,000 vessels annually. It is anticipated that berthing and deberthing process may take about 1 hour in each occasion. So 1 hour of turbulence in each occasion, berthing and deberthing. So if your vessel stays there for say 8 hours, so after 8 hours, the soil is not going to settle. It is a mud, and it is a colored kind of a water, and which will always be some kind of what we call it as volatility will be there. Suspended materials will also be there, and that remains to be in equilibrium for the side, that is for the slope. Now, during this operation, the hydraulic condition will be definitely turbulent, as a result of which the dredge slope will be vulnerable to erosions. Based on the said assumptions, as well as depending on the velocity of disturbance, the erosion rates have been estimated. What result we got is that if we dredge the slope at the butt pocket in 1 in 8, then it is safe, because if we allow that particular slope of 1 is to 8 to be disturbed by the hydraulic turbulences generated from ship's movement, then the average critical velocity of 1.15 meter per second, even if that remains so, it is found that the dredge slope will be eroded at a low rate varying from 0 to 0.1 meter per year. So in the case of 1:8, erosion rate is 0 to 2.1 meter per year. Now corresponding to the repeated erosion, as I said, 1 hour in each berthing operation, the eroded slope will come to 1:6.5. 1 vertical is to 6.5 horizontal, and accordingly it is noted that it is noticed that no further erosion will take place once 1:6.5 is formed. That means that is the condition of equilibrium. For the purpose of construction, for the purpose of dredging, for the purpose of maintaining the reclaimed mass with a particular slope, 1:8 was decided, whereas the 1:6.5 is the slope when that is will be known as the equilibrium condition. Now, the slope W software, those who have used, they know how it is to be, what are the parameters to be given an input and all. In this case, the slope W software's outputs were taken with a factor of safety of 1.4 and 6.3 under 6-week and static condition, and the coefficient of horizontal acceleration was adopted as per IIT Kanpur's GSDPA guidelines. Now, from this study, at the interface of the dredging and reclamation, the following conclusions could be drawn. In any situation when we have an interface between reclamation and dredge slope, the slope needs to be carefully planned against stability and scour both for temporary and permanent conditions. The potentiality of scour needs to be estimated after thorough examination. In the event of scour taking place due to hydraulic disturbances, stability of the eroded slope is required to be checked under static and seismic conditions. If the eroded slope is not safe, then suitable protection against scour needs to be done, or else the dredge slope needs to be flattened to the required extent. The more the dredge slope will be flattened, it can come to equilibrium, then nature will take its course to keep it like that. Like in various banks of various rivers and seashores, the slope, there nobody dredges, there nobody reclaims, and hydraulic turbulence occurs as per tide, as per wave generated by wind, etc. So there we have seen the kind of equilibrium condition. It is remaining there for year after year. Here, that particular configuration of equilibrium is of importance. Also, the factor of safety of eroded slope is lesser than that of the initial geometrically demanded slope. Such factor of safety of eroded slope technically satisfies the requirement of the intended purpose of short-term and long-term stability of the dredge slope, as well as facilitating safe operation of vessels at berth. With these things, I will not now request Mr. Krisha Humarun of Ocean Engineering Department of IIT Madras to kindly share one video which I have sent to him for showing to the participants, from where people can see the activities in this particular project. So, gentlemen, what I want to say is that this is very critical. You are dredging. Or what you are dredging? You are dredging in front of a reclaimed mass. So you are disturbing the original seabed, the taken out muds, the filled up soils, everything you are disturbing, and your ships will come there to disturb your slope. So you have to design it properly. That is the objective of this particular presentation to be conveyed to you. Thank you very much. Namaskar. Bye. Namaskar. If anybody has any question, I'll be able to say something, whatever I know about